What if the light reaching your eyes tonight as you gaze up at the sky carries within it the primal cry of the universe at the moment of its birth? And what if that's not a metaphor, but a physical fact? In 1965, two engineers were tormented by a noise they simply could not eliminate. They suspected pigeon droppings and scrubbed their antenna clean. The noise remained. That noise turned out to be the birth cry of the universe, 13.8 billion years ago. This light, known as the cosmic microwave background, or CMB, is passing through your body at this very moment. Your eyes cannot see it. Yet it is undeniably there, raining down from every direction, from every corner of the cosmos. Let's think about what this means. We may be living, right now, inside the light of the universe's first moments. Today, I want to explore what this cosmic fossil light is telling us. By the time this video ends, the way you see the night sky will have shifted at its foundations. You'll realize that what you're looking at is not merely a field of stars, but the memory of the universe itself. Chapter 1. The Day the Universe Became Transparent. What do you imagine the universe looked like in the moments after the Big Bang? Stars, perhaps. Galaxies. That's what we might picture. But reality was something else entirely. For the first roughly 380,000 years, light could not travel anywhere in the universe. To be precise, photons existed, but they couldn't reach anywhere. The early universe was like being trapped inside an extraordinarily hot fog. Electrons and protons existed in a separated plasma state, and photons, particles of light, collided endlessly with electrons, unable to travel in a straight line. The universe was opaque. Then, roughly 380,000 years after its birth, the moment the universe's temperature dropped to around 3000 K, something happened. Electrons and protons combined to form hydrogen atoms, and the obstacles blocking photons' path vanished. The universe became transparent. Scientists call this the recombination epoch, the moment the cosmic fog lifted. And the photons released in that instant have been traveling for roughly 13.8 billion years, and they still fill everything around you. The CMB is precisely the echo of that light. This is not a metaphor. We are still living inside the light from the moment the universe first became transparent. The past is alive within the present. But this light speaks of more than just the moment of birth. Within it were etched the seeds from which galaxies, stars, and even we ourselves would one day emerge. Let's explore what those seeds actually were. Chapter 2. The Fluctuations that Sculpted the Universe. Earlier, I said the CMB is nearly uniform across the entire universe. But that word nearly is everything. If the universe had been perfectly uniform, nothing would exist today. No galaxies, no stars, no Earth, no you. According to inflation theory, proposed by physicist Alan Guth in 1980, quantum fluctuations at the instant of the universe's birth, infinitesimally small differences in density, were imprinted across the entire cosmos. In an almost incomprehensibly brief period after the Big Bang, the universe expanded with explosive speed, stretching those fluctuations across all of space. It's worth noting that while inflation theory elegantly explains the nature of CMB fluctuations, it remains a leading hypothesis. Decisive evidence such as primordial gravitational waves has yet to be confirmed. Those fluctuations survive in the CMB as minute temperature variations, roughly 1 part in 100,000 of the average temperature. Regions of slightly higher density used gravity to pull in matter, and over vast stretches of time became galaxies. In 2006, John Mather and George Smoot, who conducted precision observations of the CMB using the COBE satellite, were awarded the Nobel Prize in Physics. Through COBE and its successors WMAP and Planck, the maps of CMB temperature variations have grown astonishingly detailed. This map is nothing less than the blueprint of the universe. And here's where a crucial question emerges. If all the structure we see today, hundreds of billions of galaxies, galaxy clusters, the entire large-scale architecture of the cosmos, traces back to quantum fluctuations at the universe's birth, what does that mean? It means our very existence originates in the universe's most primordial trembling. The uncertainty of quantum mechanics gave birth to the structure of the cosmos. That you are here cannot be separated from the deepest laws of the universe. The CMB has also made it possible to measure the composition of the universe with extraordinary precision. According to Planck satellite observations, ordinary matter makes up only about 4.9% of the universe, while roughly 26.8% is dark matter and roughly 68.3% is dark energy. The world we can directly observe is only a sliver of what the universe actually is. So what should we take from this light that traveled to us from roughly 13.8 billion years ago? Let's close by exploring what the CMB whispers to us about human existence. Chapter 3. The Miracle of Seeing Directly into the Past. When I contemplate the CMB, I always find myself stopped by a single fact. This is not theory, it is a reality unfolding at this very moment. If you ever watched the static on an old analog television tuned to an empty channel, some of that noise could include signals influenced by CMB radiation. The universe's first light was already present in our everyday lives. Through precision observation of the CMB, the age of the universe has been measured at roughly 13.8 billion years, more precisely, about 13.797 billion years. The Hubble constant, the rate at which the universe is expanding, can also be estimated by fitting CMB observations to cosmological models. And so too can the curvature of the universe. Observations show that the universe's curvature is extremely close to zero, essentially flat. But here's where a fascinating mystery emerges. The expansion rate of the universe inferred from the CMB and the rate measured using nearby cosmic objects disagree, subtly but persistently. This is called the Hubble tension, and it may be the key that opens the door to new physics. The debate continues at the very frontier of science. The universe earlier than about 380,000 years after its birth cannot be directly observed through electromagnetic waves through light, because the universe before that was opaque. The CMB is the cosmic horizon of what we can directly observe with light, the surface of last scattering. Yet scientists are pressing further, searching for echoes of even older epochs through other means, such as the B-mode polarization of primordial gravitational waves. The exploration is far from over. Consider this for a moment. For thousands of years, humanity pushed toward the edges of the earth, driven to know what lay beyond the sea. And now we are looking at the very horizon of the universe itself. That is the CMB. When we observe the CMB, we are not sending letters into the past. We are reading a letter that arrived from the past. The universe, as it existed roughly 380,000 years after its birth, has been sending us a message across roughly 13.8 billion years, and it is still arriving. Let's think about what this means. For the first time in cosmic history, we have become beings capable of directly observing our own origins. The universe is gazing at itself, through us. The fluctuations born at the moment the CMB was released became galaxies, became stars, became Earth, became life. You are directly connected to the first 380,000 years of cosmic history. And now, observations from 2024 have begun to suggest that dark energy may not be constant, that it could be changing over time. The fate of the universe may not yet be written. We hold in our hands a baby photo of the cosmos, and within that photo are the seeds of our own existence. The more science reveals, the deeper the mystery grows. The more we learn, the more we realize the vastness of what we don't know. Let's take stock of what today's exploration has brought into view. Chapter 4. What the Cosmos Whispers. Today, we've ventured deep into the cosmic microwave background, the CMB. Light that has been traveling for roughly 13.8 billion years since the moment the universe became transparent, about 380,000 years after its birth, still surrounds us now. That light is not merely electromagnetic radiation. It carries within it the beginning of the universe, the seeds of all structure, and the origins of what we are. Let me share 3 profound insights from today's exploration. First, the light of the past still falls upon us. The CMB is light released at the moment the universe first became transparent, roughly 13.8 billion years ago, and it is passing through your body at this very instant. We don't imagine the past through memory. We are literally, physically bathed in it. The history of the universe is still unfolding. Second, fluctuations sculpted the universe. The minute temperature variations imprinted in the CMB, roughly 1 part in 100,000 of the average temperature, are the blueprint of the universe's large-scale structure. Without the quantum fluctuations of the universe's first moments, no galaxies, no stars, no Earth would ever have formed. Your existence is a product of the universe's most fundamental laws. Third, the cosmos gazes at itself through us. As intelligent beings capable of observing the CMB, we are, for the first time in cosmic history, entities that can directly witness our own origins. I want you to sit with the weight of that for a moment. What these 3 insights point toward is this: the universe and we are inseparable. The CMB is not a distant event from the remote past. It is a present reality, here with us in this moment. While making this video, one thought stayed with me throughout. When we look at the baby photo of the cosmos, we are seeing within it the seeds of ourselves. Is there any form of self-awareness more profound than this? The light from roughly 13.8 billion years ago is asking us a question right now. Who are you? And I find myself perpetually astonished. The more science reveals, the deeper the mystery grows. The more precisely we measure the CMB, the more the Hubble tension emerges, and the vast mysteries of dark matter and dark energy expand before us. Roughly 95% of the universe remains invisible to us. Here's what I keep wondering. If we are the instruments through which the universe achieves self-awareness, what does that mean? Is the cosmos, through us, trying to understand something about itself? And can we ever truly know what lay beyond the wall of the CMB, inside that opaque fog from which no light escaped? Science, as it stands today, has no complete answer to these questions. But it is the act of continuing to ask that carries us deeper into the universe. That is the meaning of exploration. After this video ends, and you return to your daily life, I'd like you to try something. When you look up at the night sky, what you're seeing is not merely the light of distant stars. It is the accumulated history of the cosmos. And at this very moment, the CMB, invisible to the eye, is enveloping you. If you ever have the chance, find the full sky color map of the CMB captured by the Planck satellite and spend a moment with it. Within that oval, your origins reside. We are not observing the universe from outside it. From within the universe, the cosmos is gazing at itself. Let that find you sometimes, in the middle of an ordinary day. That alone may make something in the everyday look a little different. Share your insights in the comments below. Your questions are the force that propels this channel forward. I'm grateful you stayed with this intellectual journey all the way to the end. At Mindshift, we continue to journey across the boundary between science and philosophy, exploring the nature of the cosmos, consciousness, and existence itself. From the universe's beginnings as told by the CMB, to the mystery of consciousness, to the nature of time, we'll keep bringing you explorations that shake your worldview at its foundations. Subscribe and turn on notifications to walk with us into the next intellectual adventure. Your curiosity is this channel's compass. Until next time.